In this lecture video, we are going to talk about the rules of assigning oxidation reduction reaction. Before going back, let's do a very quick review about the oxidation reduction reactions. Last time we checked that oxidation, electron loss, and reduction, electron gain. The species who lost the electron is become oxidized, and the substance or species who donate electron is called reducing agent. In case of reduction, just opposite. So the species reduced and the species accept electron or substance accept electron called oxidizing agent. For example, we can show here the magnesium reaction with oxygen, where magnesium charge 0, oxygen neutral diatomic molecule 0, but the new compound after redox reaction we find is magnesium oxide, where the magnesium charge +2 and oxygen charge -2, and this is the unbalanced reaction, but our purpose to show the oxidation and reduction. In oxidation reaction, always the number of charge will be increasing as during the process of oxidation, electron donation happens. In the reduction procedure, always the charge reduce. You can see the 0 to -2. Last time we also checked a couple of examples of oxidation reduction reaction, how we can identify oxidizing agent, reduced or oxidized species, or even the redox reaction. In the same time, we saw some daily life example or application of redox reaction or oxidation reduction reaction. Today, we are going back to our new topic, how we can calculate the oxidation number. Before going that, let's review also some example that we already did here. In this particular reaction, what happening here, the silver ion charge 1, right side C, silver 0. Left side zinc charge 0, the free element charge is 0, here the +2. So it seems here the zinc is here oxidation oxidized and reducing agent. On the other hand, silver, we can say this is reduction. So obviously reduced and oxidizing agent. Now, what is our question? Which species gets oxidized in the following reaction? So, now we can see the zinc oxidized. So, correct answer supposed to be zinc. In this reaction, If we look into the charts, hydrogen gas 0, here the 0, here +2. So these are the oxidation and these are the reduction. Now the question we have, which species is oxidizing agent and which gets reduced? So that means the question is totally about reduction part. So here oxidizing agent is hydrogen ion and hydrogen ion get reduced. See, hydrogen ion is the oxidizing agent and hydrogen ion get reduced. Now let's focus on our today's lecture part, oxidation number. What is oxidation number? Oxidation number actually assigned to an element in a chemical combination which represents the number of electrons lost or gained by an atom of that element in a compound. So in easy language, oxidation number is the number of electron transferring during redox reaction. And this is also kind of method called bookkeeping method, where we can keep track of electron. And oxidation reduction reactions or redox reaction not only happen in the ionic compounds or where involve oxygen or ions, it can also happen within the covalent molecules where actually electrons get shared during bond making. For example, we can see here the methane, sulfur dioxide, MnO4, etc. Now, we have to look into the rules for assigning oxidation number. I must say that here we have some rules, in the same times we have some exception. So when we will do practice and more practice, those kind of examples, we will be confident and sure how to calculate the oxidation number. So rule number 1, atoms of free elements have oxidation number 0. For example, sodium, potassium, calcium, magnesium, even the diatomic molecule, chlorine, bromine, oxygen, all are oxidation number 0, all have. Now, sum of oxidation number of neutral compound 0. For example, nitric acid, sodium hydroxide, potassium chloride, nitrogen pentachloride, all the 0. How? Yeah, we are going to see very soon. Sum of oxidation number of polyatomic ion equal to ion charge. How? Let's see here. Polyatomic ion. For example, MnO4, this is negative. So, this, when we are going to calculate the oxidation number, the sum of the oxidation number will not be 0 in that case. How? Let's see here. Here, it will be ion charge. That means this is -1 charge. So how we can then assign the oxidation number, correct? So yeah, that's we are going to discuss and practice here. Before going to practice, let's see the rule number 2. Group 1 metals always +1. Group 2 metals always +2. Oxygen usually +2, except when it will have peroxide, for example, H2O2 or see the F2O, that time the oxidation number will be changes for oxygen. Hydrogen oxidation number is usually 1, but plus 1, but it will minus 1 in different exception case. So especially in metal hydride, we will see some example. Fluorine oxidation number or oxidation state is always -1. Chlorine, the oxidation state is usually -1, but there are some exception compound when chlorine make compound with oxygen and fluorine. That time the oxidation state for chlorine will be changed. In addition to, within the rule number 2, we also have the 6A element group A -2 oxidation number, group 5A oxidation number -3. So where there is a conflict between two of these rules or any complexity in assigning an oxidation number, that time it apply rules with lower oxidation number or conflicting rules. So actually when we will go for example, that times it will be very clear. So let's do first, we know the free element or the neutral compound, the oxidation number is 0. Free element, we know that why this is 0, this is not the ionic situation. Now we can calculate for some neutral molecule why the sum of the charge is 0. For example, HCl, so +1 -1, so plus 1 and -1 equal to 0. More example, for example, nitric acid, this is also 0. How? Neutral compound. So this is +1. We know the oxygen is -2 and we have 3 times 3 oxygen molecules. So it will be actually -6. So we have +1 here. So obviously this is +5 nitrogen. So +1 hydrogen and +5 nitrogen +6 and this 3 oxygen atom -6. So +6 and -6, then +6 -6 equal to 0. Let's do a couple of more examples. For example, hydrogen sulfide, neutral compound equal to 0. How? We know the hydrogen is +1 and we have 2 hydrogen molecules, so time 2. So it will be 2. And then sulfur here is -2. So +2 and -2 equal to 0. If we look into some other example, I will make another practice problem video, so we will have lots of example. And for polyatomic ion, why not 0? Why this is ionic charge, correct? So let's see, the example is here. So for example, MnO4, this is -1. So actually the sum of the polyatomic ion charge here will be -1. So then how we can calculate the oxidation state or number for manganese and oxygen? So let's see, we know the oxygen. So in that case, what we could do, we know the oxygen is -2. So in that case, we have 4 oxygen. So the -2 times 4. And we have this way, the polyatomic ion charge is -1. And then what we will get, let's consider the unknown Mn charge is x. We are going to calculate, correct? So let's consider this is x. So here our charge x -8 equal to -1. Then the x equal to 8 minus 1 equal to 7. So that means this manganese charge oxidation state number will be +7. So this is how we can calculate the oxidation number, and we have to remember the rules that the free elements are 0, neutral compound oxidation number 0, but in case of polyatomic ion, the sum of the number of charges will be the ionic charge, equal to ionic charge, not 0. So how? You could see that one example. We could actually check more example. Let's check some other example is here. For example, the nitrate polyatomic. So that is equal to sum equal to ionic charge minus 1. How? We know the 3 times 2. So the oxygen charge here 2 times 3, because we have the 3 molecule. So in that case, nitrogen considered X. So our X and 3 times 2 negative 6 equal to minus 1. So X equal to 6 minus 1 equal to 5. So actually here nitrogen charge will be plus 5. So this is how we have to calculate the oxidation number of polyatomic ion, and the sum of oxidation number of polyatomic ion is not 0, this is ionic charge, but sum of the oxidation number for neutral compound is 0, how we show here, and also the sum of the oxidation number of neutral molecule, neutral atom or free element is 0. So let's finish the video is here. We have some example, but since I will make the another practice video, and also I can practice more into the class. So I think here I can finish this 5.1 section video.